invented this. Nobody invented it, they discovered it. It's just like science. Nobody invented oxygen. Oxygen was discovered. Math is the same way. The laws and principles of math were just created, and the world was created. But they started to discover patterns in things, and then they discovered that certain mathematical things always work. And they started this stuff around 2000 BC. So these are the steps. When we uncovered the things that they were doing, these are the steps they followed. They're the same steps you follow. So this is just a review of something you already know. With the exception of the fact that you maybe were not taught to clear fractions first. It's one of those things that doesn't have to be done in that order, but since you hate fractions, all students do, it makes sense to clear the fractions before you do the rest of the math, and then you don't have any fractions to deal with. So I personally love fractions, but since I know y'all hate them, we'll clear them first. So the first step is to clear fractions. The second step is to clear all grouping symbols. Now, you learned parentheses, but we're going to call them grouping symbols because there are more than just parentheses. Brackets, absolute value signs, square root signs, fraction bars, all of those things are considered grouping symbols. And in PEMDAS, they are the things you do first. You have to do something above or below a fraction bar before you can do anything else, because fraction bars are grouping symbol. So is a square root sign, so is absolute value signs, so there's more than just parentheses. So that's why they say grouping symbols. This is simplify each side. That takes care of addition, subtraction, combining like terms. Then this says put your variables on the left. Honestly, you don't have to put them on the left. I don't really care where you put them. Most of the time I put them wherever they'll be positive. But the left is the way we read from left to right, so that's why they said that. The last thing you do is solve for the variable. Then this, you've probably never really done before, but we will now. Adjust to a specified domain and check reasonableness of your solution. Let me explain what I mean by adjust to a specified domain. If we're doing a problem and we're trying to figure out how many people we can fit inside of a bus, and I get an answer like 44.3. That is no good because people can't be 0.3. So I would say, in that specific case, I would round down because I can't fit a third of a 0.3 of a person. So that is adjusting to a specified domain. And we're going to do it in just a minute where they actually tell you what they want the domain to be, which means you're going to have to remember all those fancy words that maybe right now you haven't thought about a lot. And then check reasonableness of your solution. Like obviously, if you get 59 million for an answer, that may not be reasonable in some place. Not for the number of people on the bus anyway. Okay, so we're going to use these steps to answer these problems. And then notice underneath each thing, these are the domains that they want us to put our specified answer to. So that's probably going to be the first time you've ever really dealt with that, but it won't be the last. You'll see a lot of that from now on. We do a lot of that in calculus. So, okay, so first thing we're going to solve is it says clear the fractions first. I don't have any. So clear the grouping symbols. So I'm going to clear my grouping symbols first. Now, two ways you can clear this grouping symbol. What's the first way? Y'all know this one.
Multiply.
Multiply by 2. Just distribute the 2, and that would get rid of it. That's why the parentheses are there, to indicate multiplication. That would certainly get rid of it. However, as a mathematician, I'm always looking for the most efficient way to do something. Fastest, most efficient way.
So can you add the
Oh, thank you. You can cancel the 2's because there's one on each side. So it would actually be easier to technically divide by 2. Because if I divide both sides by 2, they cancel, and I don't need to distribute. That's more efficient because if I multiply the 2 through, now you're going to get the same answer either way. But if I multiply the 2 through, I'm operating with larger numbers. Larger numbers, more possibility for mistake. If I eliminate the 2's because there's one on each side, then I've got smaller numbers to go. So let's do that. I'm going to eliminate those because there was one on each side. And I'm left with 3w plus 1. I no longer need the parentheses because they were there because of the 2's. Now it says to simplify each side.
So can you get rid of the 17 first, or would you add the w's?
Doesn't matter.
So add the w's.
When it says simplify each side, they mean if you have like terms, combine them. I don't. So let's go ahead. In this case, on the instructions, they said put your variables on your left.
go ahead and just put plus 18? Oh,
Nope. Because that would be a mistake.
I'll be-
Now I've got to get rid of the 1, because I would like the W to be by itself, so subtract 1. So I got 8W equals 16.
W equals 2.
Uh-huh.
I love these equations.
Okay, so now we have to make sure that we adjust our solution to the specified domain. So you just have to ask yourself, is 2 a real number?
Yeah.
It is. So then the answer already is part of the specified domain. I'm just going to put it inside of a solution set because that means I checked it. Solution set are the funky brackets. Actually, they're called braces. So the solution to this equation on this domain is 2.
So
All right.
if you don't put it in the brackets, is it wrong?
I'm going to go with yes. Okay, on number 2, I didn't think about it because it is. Okay, on number 2, clear the fractions. We're going to clear fractions first. Does anybody remember how to clear a fraction?
You get the same denominator and then subtract. No,
I don't have to
wrong.
subtract
Okay,
them.
then.
You multiply by the denominator. Whatever denominator you're trying to get rid of. Now, in this case, it's going to work out nicely, but if we have multiple denominators, then you can clear one at a time if you want to. Or you can clear them all at once if you think of what the common denominator would be. This one works out nicely because the first denominator that I happen to have is 16, and that's going to clear the denominator on the other side as well. So we're going to clear the 16. If you multiply one side by the denominator, you have to multiply the other side by the denominator. All right, so now, real quick, we're going to have a conversation. Multiplying by 16. Multiplying by 16. Okay, before I do this, let me ask you guys a question because this always seems to be a confusion. If I have how many terms are listed right there?
3.
Good, okay. If I have how many terms are listed right there? 1.
What?
Okay. If I have how many terms are listed here?
2.
1.
Then you say something.
How many terms are listed here?
2.
2.
Yes. So is it only with addition that it makes it 2 separate ones, but if you're doing multiplication, division, then
Okay,
all together?
so what separates and defines number of terms?
Division,
Number of-
addition or subtraction?
Addition or subtraction is the only thing that separates terms.
No,
So
no.
this is all one term because it is only separated by multiplication. This is all one number. Because this actually can be written as 14xyz squared. This is all one number. This is all one number because it is only separated by division. And the only thing that can separate terms is addition and subtraction. Now, what if I do this? Now how many terms are there?
1. But it's all
1 because it's in parentheses, and a parentheses means it is grouped as a term. That's what parentheses are for. Okay, so the reason that's important is because I need to know how many terms are on the left side before, well, it doesn't matter, but how many terms are on this left side and how many terms are on the right side? How many terms are on the left side? Before I put the 16, how many terms? 1. How many terms were on the right side?
1.
1. Which means when you multiply on the left-hand side, you only use the 16 one time. When I multiply on the right-hand side, I only use the 16 one time. I don't do 16 times 3/8, 16 times x, and 16 times 1. You use it once.
Are you using 16?
Because it's all one, because it was up there in this denominator.
Okay.
So it's all one term. Okay, that's important. This is So over here, when I have 16 and a 16 on bottom, what happens?
The 16 gets canceled out.
It cancels. That's the whole reason we did it in the first place, was to cancel the denominator. So this 16 is now gone, and so is that one. So on the left-hand side, all I'm left with now is 3 times x minus 4.
So on the right side will affect everything.
Okay, so now what on the, well, how many terms are on the right-hand side?
One.
One. So you use it one time. Let's use it right here because this makes perfect sense. If I have a 16 on top and an 8 on bottom,
You get 2.
it's 2. 8 goes into 16 2 times. Now I still have a 3 out there
So
though.
multiply.
So now you got to multiply the 2 and the 3,
It'd
and
be
you're
9.
left with 6.
Well, if it's, okay, I thought you should exponent, okay? What's the big deal? I need you.
Now, we need to, that was all step 1, clearing fractions. We've now cleared our fractions. We can move to step 2 to clear our grouping symbols. My grouping symbols are there to indicate to me that I need to multiply, but I can be a little bit more efficient here.
You divide.
Divide by what?
3.
Divide by 3. If you divide by 3,
You get 2.
this 3 cancels and leaves just x minus 4 on the left. And that 6 cancels and leaves 2 times x plus 1 on the right.
I'm starting to get the hang of this.
Good. Alright, so then now I go ahead and distribute my 2. So now I have x minus 4 equals 2x plus 2. Now we're just solving. So this says put the variables on the left. I actually think this time I'm going to put them on the right. Why would I do that? Keep it positive. If I move my 2x to the left, this x is different negative. I'm going to keep them positive by moving this one to the right.
So it's just a positive x.
So I moved my x's to the right, I moved my numbers to the left, and I end up with x equals negative 6. Okay, so now we have to make sure that we're inside of each domain, and it's giving me 2 separate domains. So let's talk about A first. A is an integer. Is negative 6 an integer?
Yes.
Yes. So that gets to go inside my solution set for A. Anybody real quick remind us what integers are?
1, 2, 3.
1, 2, 3, 4, 5 are integers.
And then into the negatives too.
And into the negatives as well. 0, negative 1,
So
negative 2.
isn't it like every number basically?
No.
What's that?
Negative 3/2 is not an integer.
Okay, so every whole number.
Okay, so this is the problem, and I don't know how we fix this. Because the next thing says whole numbers. So if that's integers, what are whole numbers?
Positive whole numbers?
Positive. Whole numbers are 0, 1 to all the positives. Integers are 0, the positives, and the negatives. Non-fractions. Whole pieces. So B, is negative 6 a whole number? No. So what do I put for my solution set for 6? Because it's not a whole number for B. Anybody know what you put?
Absolutely.
You could put either the empty set, which would just be squiggly bars with nothing in between, or you can put the 0 with the slash across it. That means there is no solution to this equation that fits this domain. Now, there's a solution. It's negative 6. But there's not a solution that fits this domain. That's what it means by applying to a specified domain. Everybody good? Okay. Let's solve number 3. Clear fractions. I don't have any. Clear grouping symbols. I don't have any. Simplify each side. It's pretty simple already. Put variables on the left. Okay, it's already on the left, but let's move the other number to the right. So that would make this x squared equals 49. Then solve. How am I going to solve this? Take the square root. When you do that, you get x equals equals 7 and x equals -7. Because anytime you take a square root, there are always two answers. Because -7 times -7 is also 49, right? So, all right. So for A, I got to apply this to the specified domain. They ask for the positive numbers, that'd be 7 for A. And for B, they ask for the real number. -7 and 7, they're both real. So far, so good? Okay, on problem number 4, this one looks a little bit different probably than much, I don't know how far you guys go when you do quadratics and go on anymore. It's been so long since I've done that before. But don't let this craziness throw you off. Do not FOIL this out. They have done you a big favor. They have put this in what we call factored form already, which means you have two separate equations already written for you. If you FOIL it out, you're going to get yourself in a big mess. You're going to end up having to, where you factor it and get back where you started. So don't do that. You're just going to take each piece and set each separate piece equal to 0. The reason for that is because they're saying multiplying all of this somehow equals 0. Well, the only way something can equal 0 in a multiplication problem is if one of the two numbers is 0, right? Any number times 0 is 0. So if this is 0, then that would make all of this equal 0. And then this is 0. So that's why you can do this. You set each piece equal to 0. Okay, then you just solve each piece separately. So first thing I'm going to do is add 3. And then divide by 5. So I get x equals 3/5 for the first piece. And x equals -4 for the second piece. Now we have to apply the domain restriction. Rational numbers. What is a rational number, and are these rational numbers? Are they both rational numbers in this one? Let me give you a big hint in case you've forgotten.
Oh, ratio.
No,
No,
so
fraction.
it would just be the fractions.
But aren't all whole numbers also fractions?
Yeah, -4 for that.
-4 over 1. So
Is
this is,
that-
they're
is that how
both,
we write it?
no, you can just write this -4. They are both rational because they can both be written as fractions. So that's A. What about B?
A, B, both. No, no, my bad, just A, just A.
Just -4. Alright. Now, number 5, we're moving now to what we call literal equations. Literal equations are equations that have not as many numbers, mostly letters, and they're just asking you to solve for the indicated variable. So right now, this particular formula that has something to do with force is solved for f, because f is by itself. Well, they want me to adjust this and instead get m by itself. We do this all the time. You do it all the time in science because sometimes you need the formula to find distance, and sometimes you need the formula to find rate. Sometimes you need the formula to find time, and it's all the same formula. You just rearrange it. You use that basic triangle, you know what I'm talking about. Do the same thing for mass and velocity. Anyway, same process. We're just trying to get the new variable by itself. So we're trying to get m by itself. Now, don't let the way they wrote this bother you. This g is really on top. Just because it's next to it, I mean it's on top. Because g would be over 1, so it'll go down top. So that might help just to write it that way first of all. So I'm going to write this f equals g m e over r squared. Now, we're trying to get m by itself. So we're going to follow the exact same steps to solve an equation. First thing we're going to do is clear the fraction. How do we clear a fraction? Multiply by the denominator. So, if I multiply this side by r squared, I also have to multiply this side by r squared. So I now have fr
Why does it go to F?
Because if I multiply the right side by r squared,
Okay.
anything you do one side, you have to do the
I
other.
see.
Okay, now, I need to get m by itself, and right now it has a g and a p still with it. So I'm trying to get this m alone. How are those g and p being held into the problem? How to get rid of something that's there by multiplication?
Alright.
Okay, let's do that. Since they're both there by multiplication, let's divide them both at the same time. Those cancel, and you're left with m equals fr squared over g. That was easy enough. Next one's maybe not quite as easy. Okay, next one. Surface area. This is the formula for surface area of a rectangular prism. I need to solve for h. I need to get h by itself, but I have a small issue. I have an h here and an h here. And before I can get h by itself, I have to get all my h's together. So we're still going to follow the same process that we've been using for the fractions, for grouping symbols, blah, blah, blah. So let's clear the fractions. Oh, I don't have any fractions. Don't clear the fractions. There's not any. Clear grouping symbols. In this case, it is not easier to divide first. No. Yeah, we're going to go ahead and multiply. So go ahead and distribute the 2L. That's an L, by the way, for leaves. So I have S equals 2LW plus 2LH plus 2WH. Now remember, I'm trying to get H by itself. So let's get rid of everything that doesn't have an H. So these two things both still have an H. This one doesn't. So let's subtract it, move it to the other side, get rid of it, kick him out. He has to go next door. Alright,
Can you cancel out the two?
now, yeah. Okay, now I have a problem still. I cannot combine those H's because they're not like terms. So instead, the only thing I can do when I get to a position like this is factor out the GCF of H. See, they both have an H in them. So I'm going to factor it out. Or basically what you're doing is you're undistributing the H. So I'm going to leave the left side just like it is. It's S minus 2LW. I'm not messing with that yet. And I'm going to take an H out. If I take an H out of this piece, I'm left with just 2L. And if I take the H out of this piece, I'm left with just 2W. Because if I were to redistribute that H, I would be right back where I started. Make sense? So what looked like it was 2 H's, I've now made into 1, which is what I needed because I'm trying to get H by itself. Okay, now before I do anything else, how many terms are there on the right-hand side? 1. Good. Because this is in parentheses, and so it indicates it's all one term. Now, that term happens to be two separate values, separated by multiplication. I need to get rid of the parentheses piece. It's there being multiplied, so how do you get rid of it? Divide. And you can divide by the whole thing. 2L plus 2W. If I divide this side by 2L plus 2W, I have to divide this side by 2L plus 2W. And I'm left with H equals S minus 2LW over 2L. That one was a little bit tricky. All the rest of it pretty easy. Okay, so this is your assignment. It's exactly like what we just did. Do not forget that you have to apply the domain specifications after you solve. Solving and getting an answer isn't enough. You have to make sure that it fits inside Yes.
You say we can distribute also,